Welcome to the lecture 7 of the video lecture series of Engineering Mathematics 3. We have already started the first chapter, that is Laplace transform. We have covered first shifting property in previous lecture. Now today we have to start the next property, that is second property, that is second shifting property. Okay, so second shifting property. Okay, so now what is this? First let us see the statement. If Laplace transform of f of t is equal to f of s, okay, if Laplace transform of f of t is equal to f of s and capital F of t is equal to given small f of t minus a, okay, just remember this, capital F of t is equal to f of t minus a for t is greater than a and is equal to 0 for t is less than a, then Laplace transform of capital F of t is equal to e raised to minus as into f of s. Okay, so this is the property, that is second shifting property. Okay, what is this property? Let us see once again. If Laplace transform of small f of t is equal to f of s and given capital F of t is equal to small f of t minus a, that is in the form of t minus a for t is greater than a and is equal to 0, this second term must be 0. So 0 for less than t is less than a, then we can say that Laplace transform of capital F of t is equal to e raised to minus as into f of s. Okay, now how this is so? Now let us try to solve these examples, examples depending on this property. So example number 1. Find Laplace transform of capital F of t if f of t is equal to t minus 3 raised to 5, okay, for t is greater than 3 and that is equal to 0 for t is less than 3. So this is the example of second shifting property. How to identify this? How to identify that this example is of second shifting property? So in that, if you observe this function t, this is in the form of t minus a, okay, t minus something. So t minus something, and whatever there is, that is something, that should be here, t minus something. Okay, so t minus a, t is greater than a is equal to 0, t is less than a. Okay, so this should be there. And one more important term to identify, that is this 0. Second term must be 0. Okay, now how to solve this? So solution. Okay, given capital F of t is equal to t minus 3 raised to 5 for t is greater than 3 is equal to 0 for t is less than 3. So here is the small f of t. So how to find the small f of t here? Let us see this. So let small f of t is equal to, look at this, which is very important, how to find f of t. So whatever there is a t minus a, okay, so that minus a we have to hide. And what will remain here? If you hide this minus 3, what will remain? T raised to 5. So this f of t is your t raised to 5. Okay, in this way we have to find the small f of t. Maybe you know how to find Laplace transform of this. So Laplace transform of f of t is equal to Laplace transform of t raised to 5. Okay, and that is equal to, what is Laplace transform of t raised to 5? 5 factorial upon s raised to 5 plus 1, that is 6. Okay, and what is 5 factorial? 5 factorial will be 120 divided by s raised to 6. So this is value of small f of s. Now by using second shifting property, Laplace transform of here capital F of t, okay, capital F of t is equal to, what we have to do, just what we have hide previously, that is minus 3. So here e raised to minus 3s into f of s. What is f of s? 120 divided by s raised to 6. So this is your answer. 120 into e raised to minus 3s divided by s raised to 6. This is your answer. Okay. So this is so easy. Now let us see another example. So in second shifting property, the first shifting property also can be given. So how that? Let us see. Example number 2. Find Laplace transform of capital F of t. Okay. If f of t is equal to given e raised to minus 2 in bracket t minus 3 into sine of 5 in bracket t minus 3, okay, for t is greater than 3 and is equal to 0 for t is less than 3. Okay. Now if you observe this example, okay, what is given? F of t is equal to e raised to minus 2 in bracket t minus 3 into sine of 5 in bracket t minus 3 is given for t is greater than 3 and that is equal to 0 for t is less than 3. Okay. Now what is small f of t here? So small f of t is, look at this. So this term is your a, so that means we have to hide 3. So here is there minus 3 and here is also minus 3. So if you hide this minus 3, what we get? What we get? E raised to minus 2t and here it will be sine of 5t. Okay. If you hide this minus 3 and minus 3, you will get e raised to minus 2t and here sine 5t. Now how to find Laplace transform of this? So this we have solved in property number 1, that is first shifting property. So for that what we require? We require to find, first of all we have to find Laplace transform of sine 5t. After that we have to use first shifting property, and after using first shifting property we have to use again second shifting property. So let us do this. So first, Laplace transform of sine 5t is equal to, what is Laplace transform of sine 5t? 5 upon a square plus 25. Okay. And after that, by using first shifting property Laplace transform of e raised to minus 2t into sine 5t, okay, is equal to, this can be written as this is f of s, 5 upon a square plus 25 at s is equal to s plus 2. So if you put this value here, what we get? 5 upon, in place of s we have to write on s plus 2. So s plus 2 whole square plus 25. Okay. So if you again simplify this, what we get? 5 upon, if simplify this, s square plus 4s plus 4. So 4 plus 25, that will be 29. So this is Laplace transform of e raised to minus 2t into sine 5t. But we have to find Laplace transform of capital F of t. So therefore, by using second shifting property, Laplace transform of capital F of t is equal to what? Just what we have to do, what we have hide in the examination, that is in example, that is minus 3. Okay. So 5 as it is, e raised to minus 3s divided by s square plus 4s plus 29. This is Laplace transform of f of t. Okay. So in this way we have to solve the numericals in the second shifting property. Now let us take some examples for the homework. So homework, example number 3, find Laplace transform of capital F of t if f of t is equal to e raised to 2 in bracket t plus 3 into cos of 5 in bracket t plus 3 for t is greater than 3 and is equal to 0 for t is less than 3. So now what is hint here? just we have to hide here plus 3, okay, plus 3, and finally in answer hide plus 3 and find small f of t, okay, and finally use second shifting property, okay, by putting e raised to plus s, okay, e raised to plus s we have to put. Why? Because it is plus given, that's why we have, our answer will be e raised to plus s, okay, remember this. If the minus is given, t minus 3 is given, then we have to write down e raised to minus s, but if the plus is given, then we have to write down plus, okay. So example number 4, find Laplace transform of f of t if f of t is equal to e raised to minus 3 in bracket t minus 4 into t minus 4 raised to 4 for t is greater than 4 and is equal to 0 for t is less than 4, okay. So hint, what we have to do here, hide minus 4, okay, find f of t, after that find Laplace transform of f of t, okay, using first shifting property, then use second shifting property, okay. So in this way we have to solve these examples. So I hope you have got what I have told you up till now, and what is the second shifting property and what is the first shifting property, that also you have understand, okay. Thank you very much. But in next lecture we are going to start the third property, that is change of scale property, okay. Thank you very much.